Hello, everybody. Okay, come. This month, right, the notes, there's chapter 5. Hi. Hello. Hi, Zoe. Hi, Melvin. Okay, guys, sup. Now, before we start, right, the notes you all get today, this month is got chapter 5. So if you open, there's one booklet inside, which is chapter 1 revision. That's what we're going to do today, lah. So I will use 1 week and only 1 week to revise chapter 1 because it's quite a useless chapter. You only will see in your first term exam. Okay, so I only revise it for the sake of your first term law. Okay, so I understand that quite a lot of you, your first term exam is quite behind, like some June, some July, but there are small percentage of you all, your exam is May, right? Some of you all. Yeah, yours is next week. Yeah, I understand. So because, right, now our first term seminar, bio is definitely after some of your exams. So those who have an exam this week or next week, right? Definitely the seminar, right, I can't revise, do revision with you all, right? Because if you see bio is on form 4, where it's on June 4th. Yours is this Friday. Okay, so for those who have any exams soon, right, I have already posted. Okay, take a look at your GC, your Google Classroom. Okay, I just put Sri Petaling at simply one. I think most of the branches I already posted this. Okay, which I already posted the first term seminar notes here. You can see the seminar notes is already here, right? So on the seminar day, right, I actually will revise chapter 2. 2.2, 2.3 to be exact. So 2.1 actually quite important, the organelles part, right? Okay, yeah. So for 2.1 and 3.2, there's a video for here for you all to watch, which is last year punya seminar video. Okay, so I'm definitely sure that if you're having an exam this week or next week, right, definitely you're going to have form 4 chapter 2. So 2.1 very important. Please go and watch this video. If you have chapter 3 in your exam, yeah, there's 3.2 here also, which is the active transport, passive transport, that one. Okay, so and here got one more video, but this video is conducted in Mandarin. So if you understand Chinese one, you can watch this one. This one is the amoeba paramecium, that part. Okay. Then what I want to say already. Yes. So regarding the seminar, like I say, it's free one, this first term seminar. So if you look at your GC, right, the admin, I think yesterday or a few days ago already posted this thing here. So you don't have to register for this seminar because it's free one. On the seminar day itself, right, we will post the meeting ID in Google Classroom. You just have to click and then you can join already. Okay. So, but for the notes, right, how to get the notes? Okay, you just click into this link, then you'll be directed to this website. Okay. Then on top here, there's this thing here called I want hard copy notes. All you just have to do is just click. It's just a very obvious one. Just click, and then you just have to fill in this form, and then they will post Laju to your house. Ta-da! So easy. Free delivery, better than Shopee, better than Lazada. Don't need use coupon one. Okay, you can. It's free right, this semester, so you can try any subject you want. Understand? Last year first term video link is at GC which part? You're in which branch, Zoe? Because I think maybe 1 or 2 branch I might left out. You have to click classwork. PU got already one. I think PU got already one. PU. Maybe I haven't posted. I don't know. Classwork. I haven't posted yet, so sorry. I haven't put in PU. Okay, later I'll put. So sorry, yeah. So you just I show you just now, it'll be the same. Okay, so it's like, let's say like Sri Petaling like that. Yeah, I left out 1 or 2 branches later. I post. Yeah, I'll post later. So the video is here also. Just have to click. So later I post that later. Okay. So yes, that's it. So seminar one, you don't have to register one. Just click, get your notes, and come during that day. The timetable for every subject is already here. Just look at it. Okay. Can black conducted in Mandarin, red conducted in English. So yeah, I just mentioned bio because there's too many subjects here already. So yeah, bio is 4th of June. Okay. Now, let's look at this booklet here, chapter 1. Now, chapter 1, like I say, very stupid chapter because, like, for example, you can see 1.1, fields and careers in biology. Meaning this part it's like, let's say if you love bio a lot, what are the things you can study, or what are the fields you can work as that's related to bio? So for example, you have medicine, like doctor, pharmacy, you have biotech, biochemistry, and all that. So all of these, you just read through yourself lah, because they just come in objective for me. I don't want to waste time here. Okay. Microbiology, for example, if you study about microorganism, genetic, you study about gene source, you study about inheritance lah, for example. Cytology, you study about cells lah. So this one, just read through only. Now 1.2, this thing also a bit useless one. Also, they only ask in objective. So 1.1, 1.2 is definitely just objective, multiple choice question. Like for example, safety protective equipment. So when you go to your science lab or whatever, physics, bio lab, what you should wear? Like you should wear gloves, you must wear lab coat, which actually in school you also don't do this, right? So you like learn for fun only, right? Okay, then the next thing, you have equipment in labs, which for example, okay, I will go through a bit this one, these two. Some of your school punya lab might have this. Have you all seen this before? Especially this one. This one is more likely you have this. Because see before. No? But you do. Oh, very good. So if you have this in your school, good. But yeah, exactly. You don't use it, right? A lot of you say yes, got, but teacher never used before. Or some will say spoil already. Got one yesterday tell me got, but inside got cockroach and all. It's called Lebo WhatsApp. Yes, in VM it's called that. Correct. In English, it's called fume chamber. So fume or asap, WhatsApp means stands for smoke. So these two, right, they look quite the same because they're like two boxes like that. But the difference here is like one is blowing air out, one is sucking air in. Okay. So this thing, why in school you all don't use it, right? Because the experiment that we do in high school is very low level, which is not, you don't require this thing at all. So what kind of experiment that you do require this thing, right? Usually are those chemistry experiment whereby you mix chemical, then you got like smoke coming out, bzzz, like that. Yeah, so if the smoke that comes out is poisonous, or we say hazardous, means it could harm your respiratory disease, it could kill you. Like for example, you release chlorine, bromine, or nitrogen dioxide. Yeah, these gases are harmful. So you will need to carry out inside this fume chamber because it will absorb these gases. So it's like, you know, it's like those exhaust fan that you have in your house punya kitchen is exactly the same function. They just suck the air out. Okay. Now, laminar flow cabinet, the air flows in the opposite direction. They suck air in and blow air out. So when they suck the air in, right, there's this filter over here that will filter the air. So you blow out clean air. Why do you need clean air? Because certain experiment that you do, right, the material that you use might be very sensitive to bacteria or dust in the air. So this thing will provide a flow of filtered air for clean work area. It means it gives you like clean air lah. Understand? So that's it. I'll just go through these two lah. So the rest, like I say, you just read through lah. But okay, I'll just mention a bit more. This thing is actually quite interesting. Some schools have, some schools don't have. It's like a shower like that. You might wonder why is there a shower in your lab. So it's not for you to go there and bathe, but it's for, let's say if you kena those kind of acid, very bad for your skin, it will corrode your skin. You might want to come in and faster pull the thing and it will wash your body. Because it wash those harmful chemicals away from your body. Your school got, yeah. Then some of y'all will tell me, oh, I got my school got one fella, he go and pull the thing. Yeah, so usually school don't have because y'all will definitely go and play this thing. Some will just off the tap so that your pool got no water come out. Okay. And this is to wash your eyes. It's like a fountain like that. Like, you push this thing here, water will come out to wash your eyes. Because in case you got your eyes kena chemical. So yeah, some of the school might have it, but you usually don't use it because you all will play. That's why your school will like probably off the water or something like that. Okay, the rest, just read through. Like I say, objective only, nothing too hard. Now let's go to 1.3, page 7. Now this one important. For this part, right, They'll definitely ask in subjective because you need to construct table and plot graph. So definitely will ask you to need to write one lah. But however, right, this part, right, the things that we learn in 1.3, right, it's not just will be used in your first term. We also be used in your experiment paper next time. So you all know, right, you all have something called Amali. You have to carry out experiment, and then you need to write report. It's part of your SPM. So when you write report that time, you need to know how to draw table, plot graph. So what we're going to learn here is actually quite useful lah. All right. So there's two types of graphs here: line graph and bar graph. Histogram, I'm not going to talk about it because in bio we don't really use histogram. Plus, it's something you learn in maths. Now, these two graphs, no matter what graph you draw, what table you draw, number one, okay, we look at table first. Every table, right, the left column and right column is what difference. So left column, usually what we need to write here. Does the report need to draw apparatus that is set up for experiment? Don't need. No, don't need. Don't need to draw. Last time need lah, now no need. But bio all the time actually don't need to draw one. Okay. Yes, so can you guys tell me what do you need to write here? What's the data here? Remember or not? Manipulated and responding. Yes, very good. So MV and RV basically. Okay. So if you don't know this by now, yeah, now please remember lah. From last time primary school one now, right? Here's always your manipulated, right? And when you write your manipulated variable that time, right, don't forget to bracket the unit behind. If you write temperature as your manipulated variable, you need to bracket degrees Celsius. Rate of evaporation, this is second S. Yes, so bracket the unit. And unit don't need to write here one. So if you don't know this now, I let you know, unit don't need to write here because some of you don't know. Yes, you just leave it empty, write the unit one time at the heading canary. The table is just that simple. Now for graph, by now, I need you all to remember this, not just for bio, but for chemistry, physics, maths. At maths also the same. Your x-axis, the horizontal plane, is always your manipulated variable. So the thing that affects your experiment will be on x-axis. Actually, this one you need to write over here. Here a bit wrong. And then same unit, very important. So y-axis is also same. You usually is right on top here. And y-axis is always your responding. You also should remember this already. And also bracket the unit behind. Okay. Now, the title of the graph. Usually, we are not required to write the title of the graph, but from the title of the graph, we actually can confirm the RV, MV. Let's say you're not sure the MV, RV is what. When you read the title of the graph, right, you should know already because the format is right. We always write graph of MV against RV. Graph of RV responding against manipulated. So it's responding against manipulated. Okay, so it's rate of evaporation against temperature. Okay, then we have another graph over here, another different experiment, whereby you can see x-axis type of fruit juice, y-axis concentration of vitamin C. So here the same thing. X-axis always is manipulated variable, and responding is on your y-axis. So this experiment, I'm using different fruit juice, and I want to test different fruit juice punya concentration of vitamin C. So it's a legit experiment that next time we will do on this one actually. Okay, so the title of the graph will be graph of RV against MV. So the same thing, RV is here, concentration of vitamin C against types of fruit juice. Now, I want to ask you something. Do you all know when to draw bar graph, when to draw line graph? Because in exam, they won't tell you, and different experiment, we are required to draw different graphs. Why I want you all to know this, because in SPM, recently, this exact experiment came out, and there's some of your senior, they'll draw this one. So I need you all to know this. Okay, who can tell me? Bar is for what kind of thing? Line for what? I'll give you a hint now. The MV, the manipulated variable, is where we're going to look at. So the manipulated variable will determine the graph that you're going to draw. So what kind of MV will require line graph? What kind of MV require bar graph? Line graph is for time. No, so be more specific than that. Bar is those with different ending result. Line is for one only. No, doesn't make sense. Bar is mostly temperature. Okay, now let me just tell you that. Okay, it's all right. Don't worry. Now, mostly temperature. No, there's also a lot of things that can be on line graph that is not temperature. There's also a lot of other things. Okay, like concentration, this and that, length and all. Now, very simple. Whenever your MV is basically, how to say, quantitative, means something that you can count, got number one, okay, you can quantify it, got unit one, then it will be line graph. So quantitative means you can use number to quantify it, you can measure it with units one, like temperature. Understand? Okay. But for this one, it's the opposite. So if you don't write down, no number, no unit. Look at here, type of fruit juice, there's no number. Fruit juice is what? Apple, orange, pear. There's no 1, 2, 3, 4, and there's no unit for it, right? So it's the opposite. And plus, right, there's one more thing you can confirm whether is it line graph or not. Okay, temperature, we'll write what? 1 degree, 2 degree, 3, 4, 5. Now, if I ask you, between 1 and 2 degrees Celsius, is there any data or any value between 1 and 2 degrees Celsius or not? Yes or no? Yes or no, guys? Is there anything between 1 and 2? Why no people answer me, only 1 people or 2? The answer is yes or no? 1 or 2, 1 degree, 2 degrees got unit, got data or not? Yes, the answer is got. Okay, so for those who say no, it's like this. Between 1 and 2 got what? Got 1.2 degrees Celsius, 1.3, 1.4, 1.5. That's why we can use line, because if your line like this means there's data here, there's data here, there's data here, there's infinite data, right? There's 1.111, 112, 113, blah, blah, blah. There's so many. Meaning you can do this 1.2 degrees Celsius, the rate is like that. But between apple and orange, there's no data. Apple is apple, orange is orange. So basically, right, for bar graph, right, you have like your own grouping, your own category like that. Apple is apple, orange is orange. There's nothing in between. That's why here you see that your graph got nothing. That's why you don't draw a line. If you draw a line, means there's something here, which there's nothing. Understand or not? Okay. So one more thing you can help you to remember is if they always say type of blah blah blah, that is definitely bar graph. Okay, you cannot quantify it. There's no number for your MV here. Okay, it's that simple. Now, one more thing here, the bars, right? Now, when you draw bars that time, right, they won't ask you this statement, but you just need to know when you draw bar. The bars should be how punya width. Every bar punya width obviously must be the how the bars should be. Same width. Yes, correct. Winston Zoe. And equal, use the word same lah, huh? And how are they spaced? The space also the same. So an evenly spaced. Okay. Now we're going to practice table and graph. 3 examples here. So the first one, exactly the same as this one here, the vitamin C experiment. So an experiment was carried out to determine concentration of vitamin C in orange juice and lemon juice. So remember, left-hand side always is your manipulated. That is your type of fruit juice. No unit. Then right-hand side one, concentration of vitamin C. Unit, already written here, milligram per milliliter, ml. So they say the orange juice and lemon juice concentration was 3.5 and 5 respectively, meaning orange juice 3.5, lemon juice 5. Now, the decimal need to be the same. Even though 5, usually we just write 5. But here why we must write 5.0 is because of this one. The decimal, here got 1 decimal, here also must have 1. It must be the same. Okay, so if if there's 3.51, here must write 5.00, means all must be the same. Now, draw graph. So x-axis, always your MVR. So type of purchase. Y-axis, concentration of vitamin C. mg stroke ml. Unit, don't forget. Now, when doing bar graph, don't write your value orange, lemon, apple like that. Okay, but instead write it like this. So I move the line a bit. You're going to write like that. Meaning orange, lemon. Because when you draw bar that time, you just straight away follow the box like that. Easier. If you put like this, right, your graph is like this, very weird. The bar very weird. Okay, so y-axis, the scale, you just use 1. Every box is 1. 1, 2, 3, 4, 5. Now the 5 I write on top here, no space really. And my graph paper very small. So orange 3.5. Lemon 5. Now when you draw already, then don't forget you must type that. Okay. Now, the second one, very easy, this one. You have a few more seconds, we do the second one. Okay. The second one, a whisking tube with 100 ml of 100 gram distilled water. Actually, 100 ml, 100 grams the same. So let's say I got the whisking tube, inside got 100 gram of water, 100 ml. It's placed in different concentration of salt solution. So I put it inside salt solution. So this is your chapter 3 punya thing, the hypertonic one, if you remember. The whisking tube decreased in mass by 20, 40, 60 gram when placed in 0.2, 0.4, 0.6 salt solution. So guys, what is my manipulated? So which thing here is affecting my experiment? I want you guys to think. So if you got attend that time chapter 3 or you all should know this. So what is influencing what? What is your MV here, guys? Come on, what's your MV? Yes, Tanya, correct. So E, correct. Some more. So what is affecting my experiment here? Very obvious, is the concentration of your salt solution percent. So the salt solution punya concentration here will affect the amount of water coming out. Remember, you got more salt, more hypertonic, more water will come out. So your responding is the mass, we will say the decrease in mass of water, of whisking tube, sorry. So grams. Then just follow. Okay, you all right yourself, and then draw the table now. Come, everybody. I know I cannot see you draw the table, okay, but do it now, everyone. Then later, we cross-check our answer. Come. Remember your axis, x-axis is who, y-axis is what. We want to label with units. Do it now. Let's go. Any question you can ask? Do it now. Let's go. Let's go. If you're done already, you can try the next one first also. So simple. Okay, so I post the seminar notes and video first. They got two Google Classroom I haven't post, Sungai Long and the Puchong Utama one. So I post these two first. Okay, done. So your graph should be like this. Okay, so along with, remember, 0.2, 0.4, 0.6 here. Is it wrong already? 0.6, then 20, 40, 60. So your scale, every box, which is every 2 cm, equals to 0.2 here, 0.2, 0.4, 0.3, 0.8. Then yeah, like this. Okay, now for bio draw graph, right? Let me tell you this. Some of you make this mistake. You just have to draw the short, by the way, use ruler and pencil when you draw graph. Because pencil, you draw some, you draw wrong, you can erase. That's number one. And yeah, use ruler, of course. This line, just use ruler. So you can see that you just have to match the lowest to the highest point. You don't have to draw more, or you don't have to connect to 0. Don't need. Maybe in maths, in physics, yes, you do that. In bio, no. Okay? Everyone got that? Easy, this one. Next. So the time taken for one, okay, this one help me to change to 10:8:6. Sorry, So the time taken for 1% draw graph, use pencil. Draw graph is definitely use pencil one. Pencil. Yes, can use pencil one. The time taken for 1%, 2%, and 3% concentration of amylase enzyme to break down starch is 10, 8, 6 minutes respectively. So MV, everybody come. What is the manipulated? Yeah, you guys more respond. I call people who is your manipulated? What is affecting my experiment here? So when I use 1, 2, 3% enzyme concentration, the time taken to break down starch is 10 minutes, 8 minutes, 6 minutes. Yes, Melvin, Tanya, Yijun, very good. So the one that affect my experiment is Jiahui, correct. Wingsun is concentration now, Wingsun, not percentage. So yes, concentration of amylase enzyme. So the unit of the concentration here is percentage. Okay, then the responding is the time taken to break down the starch lah. Now this one we will learn in chapter 5, means next week. Next week we do chapter 5 already. So time taken to break down starch suspension. Okay, more enzyme, the faster the time actually. So time taken to break down starch suspension. So time taken here is minutes lah, the unit. Okay, so 10, 8, 6, 1.0, 2.0. Yeah, just follow the thing lah. 1.0, 2.0. Okay, can you guys do this yourself also? Make it quick. It's so easy, this one. So this one is the same. It's line graph also. So the question already say line graph plus concentration is number or unit. 1%, 2% between got 1.1, 1.21. So it's very obvious line graph. So just now that this one, the concentration is also the same. Concentration can be 0.234, 0.256. So there's data, there's value between each data. That's why we use line graph. So I think your guys should be done. Very simple. You should get like this. So higher the concentration, faster the time taken. Okay, done. When you guys done, we then can move to page 10. Let's go. Ready? We look at page 10. Okay, no problem. This is a very simple one. Okay, but in your first term, they might ask you this. Okay, for first term, this is quite important. Then after that, it won't be important until we do experiment. Now next time. 5, 4, 3, 2, 1. All right, let's go. Page 10. Okay, page 10 and 11, these two things will only ask in objective. Now, however, even though they ask in objective, right, but it's something that we will use to apply in bio very frequently next time. Body planes, meaning how do you cut? From which section you can cut a human body, and then you can then look from different angle. Because like since you all learned science last time, right? Human body parts, right? We can look from different angles. So there are 3 ways we can cut a human body: frontal, sagittal, horizontal. Now, frontal plane is you cut from the front. I mean, you cut from the front. You cut already, you look from the front. Okay, so you cut like this, see the bottle like that. Then when you cut like that, you will split front and back. Then you look from the front. Can you imagine, right? So last time, you all got learn what organ is you will see from frontal plane one. What's the example? What organ you all learn last time? You look from the front one, then you learn the parts of the organ. Digestive system, okay. Can some more? Got one even more specific one, like more detail. You learn very detailed about the organ one. You learn about the parts. Respiratory system, lungs, okay, also got. And one more? Yes, heart. This is the one that the main one. Right? You got to learn the right atrium, left atrium, which actually all of this we'll learn again in bio also. Just that we learn in more detail. Okay, the next one. Sagittal plane. So sagittal S, just remember, side. So you cut already, you're looking from the left and right side. See the human body, you cut like this, so you separate it into left and right. So last time you all got to learn which part of the body, which organ we look from sagittal, from the side one. That's you all remember now. Got what organ we look from the side one? Lungs don't have. Spine, no. Spine is not this one. Kidney got. Got one more. Rib cage. Rib cage is bone, not organ. Liver, no lah. Okay, got one more. Your eyes. You remember you learned the cornea, the lens, the iris is all look from the side, look from like here one. Nice. And we all learn one. Okay. Then horizontal. Okay, when you cut like this, where will you be looking? Which direction you are looking from when you cut like that? Yeah, this one also got ears, correct? Ears. Yes, is it this one? Ear is more of frontal. Because ear is like we look like this one. These are go outside from inside now. So ears actually is frontal. Ears is actually frontal. Ear are from the front. From the yeah, ear is frontal. Yes, say already. Yeah. So this time you cut already, right? You look from the top and the bottom, right? You look at this, right? You cut like that from the side. So this one only is backbone spine. Next time you'll learn about this. You look from the top. Okay. And what's inside your backbone? Can anyone tell me or not? What's inside our backbone? Spinal cord. Very good. The nerve that goes up all the way to your brain. We also will learn about this next time. Okay. Backbone is the bone. Okay. Then yes. Now in animals, it's going to be slightly different. Like those four-legged animal like cow, deer, dog, cat, lion, tiger. Okay, let me put here A, B, C. Now, can anyone tell me which one is sagittal plane or not? I mean, ask you all first, then later I show you all. Which one is sagittal? Which one you cut already, you look from the sides? A, B, or C? Which one? Let me see your answer. Come on. A, B, or C? Okay. The answer is the answer actually is B. Okay, so you see, you cut like this, you cut like that, you basically, then you look from the side, right? So imagine you cut the cow like that, you cut this thing. So this is actually sagittal. Okay, for those four-legged animals, right? You need to imagine them standing up, or you just imagine human, sagittal like this, right? You cut like this, right? See? So you cut like this already, then you just put it down. Because animal, right? Yeah, it's like human crawling like that. So it's like ching cut like that. Okay, then you go down. So when you see my bottle like this, I cut like this, then I go down like that. So it's like this, so it's this one. Yes, Melvin, I know a lot of people didn't see that. Shh, okay, don't worry. So then frontal. So frontal is ABC. So frontal A, B, or C. Okay. So again, you got to imagine cutting a human, then you put it down. Or you imagine the cow stand up, then only you cut. Remember. So answer is C. Yeah. A lot of you say A. So by the way, here got answer already. You didn't see. Okay, but whether got answer or not, you still need to understand. So you see, again, this is me, a human. So frontal is you cut like this. Right? You cut like that, then you see from the front. So imagine now this human, I put it down like that. So it's cut like this. So that is C. Okay? Understand everyone? See? The cow like that, stand up, is a human frontal. This one, A only is horizontal, because when you cut the cow like that, you'll be looking at the backbone, right? The backbone is like this, exactly the same like human. So a lot of you will think like, oh, see, this one is cut like that. So you'll think this one is the horizontal because like this. No, this one is I lie down already. You need to stand up. Everyone okay here? If everyone confused within which plane, can ask now. Yeah, don't just act that you know. You must understand one. Okay, all good. Now next page. Now this is for plants. In plants, the way we cut it is slightly different and the name is different. This one we call section. So the first one, okay, so that you cut the stem of the plant, you cut carrot, you cut beans, you cut potato, is the same. You can cut it, slice it like this, like that. So this section, you all should know one. This one quite easy. What section is this called? Like you all see the xylem and phloem of the plant last time also did the same section. Yes, this is cross section. You all actually know this one. This is not horizontal. In plants it's different. Plant we don't call it horizontal, we call it cross section. Okay, then this one you see you cut already, very long. So very long. So it's called longitudinal section. All right. C. Direction. So direction literally means up, down, left, right. So when you look at an animal or a human, yeah, which direction is which? So we'll focus on these two first. Anterior, posterior. Anterior, posterior means front and back. So if your vocab is good, post means back. So front, back. So wherever your face is looking at, that's your anterior. Wherever your back is facing, your butt is facing, that's the posterior, your back. Then superior, inferior, head and feet. So remember that Superman always fly in the air. So superior is always up, inferior is always down. Okay, superior, head on top, inferior towards the leg, bottom. Then, dorsal ventral. Now, this thing you can see is not in human, but however, it's in animals like dog, cats, like the cow just now, four-legged animals. So ventral meaning means belly. Belly means stomach here. It's called the belly. Your abs there or your tummy there. Dorsal is your back, like back as in like this back. Okay, your 背后 in Chinese, yeah, your back. Okay, so in human, why do you have dorsal ventral? Is because belly is in your front. So we will just call this whole thing as anterior. There's no point using ventral this term. Same goes to dorsal. Your back is at your back. Your back is at like your behind, literally. So that's why we don't use dorsal ventral. But however, in animal like dog, for example, or cats, their back is not at the back. Their back is facing up. Their tummy is not facing the front. Their tummy is facing down. Right? So their anterior, front, posterior, back is not the same as dorsal ventral. However, there's no superior, inferior in dogs and cats because head is here, feet is here, is the same as dorsal ventral. Understand? Same goes to fish, actually. Dorsal, ventral, anterior, posterior. So if you know, right, this fin is, by the way, called dorsal fin, and it's called ventral fin. So it's based on the direction. Okay. And finally, lateral means side, means that your left and right side. So we have that in human, left and right. In animals, their left and right is like here, left, lateral, here also lateral. Okay. So let's try a few objectives for this one. Very quick one. Actually, very easy only one. This one. Page 16. Which of the following is the section of cucumber shown in diagram 1? So, yeah, guys, which section is this? Which section is this cucumber? Like you eat nasi lemak, that section, cross section. Yeah, so remember now every time you eat nasi lemak, the cucumber, that's cross section. The tomato that you eat in your burger is also cross section. Then number 23, if you want to divide the body parts into anterior and posterior. So anterior, posterior means what? Front and back. Which plane you should use? So they are combining direction and plane together in this question. So which way I should cut, guys, to divide the body into front and back? Okay, a lot of you very fast, very good. Frontal, you cut and look from the front. So you cut like this, divide front and back. Easy. Now the heart is what towards the liver. Okay, we try to cheat. We don't want to see the answer first. Okay, so heart is which part of the lungs? The tomato in burger is not longitudinal, man. Because tomato is round now, so it's a bit hard. Tomato like this. Tomato a bit hard lah. Okay, long, cross. Long, cross. Because cross is like this. Whatever, I also don't know. Okay, so anyways, very good question. Because potato also round, right? Potato will be oval. So potato like this is cross off. You cut from the top. This cross off. So potato usually we eat like that one is cross. Tomato, very good question because tomato is round. Tomato we cut how do we cut tomato? We cut like this, right? Do we? Right, tomato we cut like that, so it's cross off. Yeah, actually the same. I know tomato is just freaking round. Okay, anyways, depending where the leaves are. So tomato is like this. Okay, very good one. Tomato is like this. So if you cut like that, will be, yeah, like that is long. Correct. Like that is long. You cut from the top is long. Yes, correct. Long. Because see potato like this. So yes, like that is long. So yeah, the tomato we eat usually is long. Like that only is cross. Yes, sorry. Long, cross. Yeah, you look at the leaves actually. It's not low E, yes, a very good one. Thank you. Okay. So, okay. The heart is what towards the liver. So heart is, liver is here. So it's always on top of your liver. So on top is superior. Okay. Lungs is what towards the heart. Lungs, heart. Is beside it. Yeah, Wing Sun correct. The answer is lateral law. So the answer is D donkey law. Last one. This part of the crocodile is what? Why not anterior? What do you mean why not anterior? Superior, why not anterior? Very good question. I know your heart is in front of your lungs, but mainly you say is beside it because you're on the same length like that. Because the answer here only left lateral. Actually, anterior also can. But yeah, the most accurate one for this question is lateral because here already superior. Actually, anterior also can. Both is not wrong. Both is correct actually. Okay. So for this one, the belly is ventral. Okay. So you just remember dorsal ventral. Just remember my name, Davin. D already, then only V, not the other way around. All right, now we have one more thing to go through. Page number 12, 1.4. Now there's something here called scientific investigation, which is something you learn in Form 1 exactly the same. Sorry, this one is wrong already. This is old syllabus one. The new one, they changed a bit already. So I got write everything here. Okay. So what is scientific investigation means, right? When you carry out an experiment, what are the steps you need to carry out before and after the experiment? So point number 4 is the part where we carry out experiment. Can you please copy this down also? Okay. Now, why we carry out an experiment, right, is because we have a problem. We want to test what is the answer for this problem. So first step, you always identify the problem. After you identify the problem already, right, you need to form a what? You guys remember what you learned last time or not? What do we form? We form a, correct? We form a hypothesis. Yes. So now if you don't know, if you forget what's hypothesis, it's like this. Whenever you have a problem, right, you need to guess the solution of the problem. So hypothesis is making a smart guess. When you guess already, you carry out an experiment to test the hypothesis. So that's what the point of an experiment is, to test your hypothesis, whether what you guess just now is correct or not. Now, in question, right, in your first term, they will ask this: state the problem statement. So problem statement is always end with a question mark because it's a problem. So the way of writing it is like this: what is the effect of MV on RV? Question mark. And hypothesis, you all remember how to write, right? Since primary school, we always say as the what increase, the what increase. In Chinese, we always say yue, this thing means as MV increase, RV increase. Now, of course, the RV can decrease also, depending on the experiment. Okay, so when you ask the question already, so how does MV affect the RV? Then you guess by saying when the RV increase, the RV how? Okay, so let me give you an example. Okay, let's say I'm a baker. I make bread for kindergarten punya children. So I think that kids, they like sweet stuff. So my bread, I put a lot of sugar inside and give the kids to eat. So 2 months later, when I visit the kindergarten, I realized, wow, why all the children all become so fat? So I start to identify the problem. So I think, what is the effect of my sugar on the weight of the student? So then I answer my own self. I guess the problem punya's answer by saying probably more sugar there is, the fatter the student, or the weight, the student punya weight increase. Then I identify the variables, the MV, RV, and the constant, and then I start planning and carrying out the experiment. So how I carry this experiment, I go to plan first. So maybe I divide the students into two groups, A and B. Group A, I continue to give them a lot of sugar punya bread. And group B, I give them bread that has no sugar. Then 2 months later, I carry an experiment that I collect the data. So I realized that the one that will give sugar from 20 kg become 30 kg. No sugar from 20 reduced to 15. So collect data is like basically drawing the table that we did just now. Okay. And then once we collect the data already, what do we do with the data? Remember? We collect the table in the data we collect the data in the table already. What do we do next with the data? I can just look at it, right? Record is collect, the same. You record, you collect already. Okay, I give you a hint. It's just now to draw graph one. So I put my data into a graph. So what am I doing with it? Yes, it's doing very good. I'm interpreting the data. Now, last time you all might learn it as analyze the data. Yeah, it's also correct, but our textbook, they use the word interpret, so we just follow. Okay, you analyze it. So you analyze, you find out that more sugar, fatter the student. So then you form a conclusion. So conclusion is to conclude your hypothesis. So just now, you will say, that's why conclusion will always say hypothesis is accepted. Meaning what you guessed just now is correct. So conclusion is like the result of your experiment. Okay? Then report, next time I teach you how to write. Okay, when we do the kerja amali and all that time. Now we don't need to know yet. Okay? So let me show you one example question of how they will ask this one in structure. So they will probably give you an example of experiment, like page number 19. You wrote too many report in your form 3. Okay, the report in your amali is very easy one. It's much more easy than your form 3 report. Trust me. Okay. Now, here, page 19, we do this question real quick. Now, I want you guys to read this sentence. A group of students carry an experiment to investigate effect of light intensity on rate of photosynthesis. So can you tell me from this sentence, don't look at the experiment, this sentence only, what's the MV? Manipulated is what is affecting my experiment? Yes, correct. Light intensity, right? And my responding is the rate of photosynthesis, right? Too easy, right? This one. Okay. So But when you do experiment attempt, you realize that, why the table here, the MV, RV a bit different. So the MV here is distance from the light source, distance of the plant from the light source, and RV is the number of gas bubble release. Now, why is it different? Because when you do experiment, your light intensity have to be different, right? It means when you do experiment, how do you control your light? When you do experiment, how do you count the rate of photosynthesis? So, therefore, this one, right, is actually theory punya variables, what we call it as actual, MV, RV. But when you do experiment, you need a different set of variables, because when you do experiment, you need something to control the MV and RV. So this one, we call it as operational. But question, they won't ask you this, that you know then can already. Okay? So obviously you all know, right? The closer the light towards the plant means the shorter the distance means you got more light, right? That's why you can see further the light, the number of gas bubble release decreases. Meaning further the light, lesser light intensity, you got lesser photosynthesis because lesser bubble, lesser oxygen come out. Okay. Now, for problem statement and hypothesis, you will use the actual MV/RV. Why? Because if you go back to the scientific investigation here, problem statement and hypothesis is formed before the experiment. After when you carry out the experiment, then only you will use the experiment punya variable, like your table, your graph, only will use operational. That's simple. Okay. Yeah. So for this one, we always copy the question. Copy here. So I give you the format already, right? What is the effect of MV, light intensity? Sorry, 2 more minutes. Going to finish already. On rate of photosynthesis. Suggest a suitable hypothesis, also will use the actual, because I need to guess the outcome. I guess the problem. You're guessing this, so of course you follow this one. So as the light intensity increases, rate of photosynthesis increases. Now, variables is always experiment punya variable, always. You ask variable is the experiment one. When you do experiment, what is the variable? Okay, so you write yourself the distance of light source, number of the gas bubble released. Okay. Okay. One last thing before we end. This thing you do yourself. Okay, but I just want to tell you, see the graph. By using table 1, draw the graph of number of gas bubbles. They already tell you here against distance of light source. So exactly like we did just now, the title of the graph, right? So can you guys last one tell me x-axis is which one? What do you write for x-axis? I know MV, so which one is the distance of light source? Yes, RV against MV, right? So this is your MV x-axis. And then number of gas bubble release per minute is your RV, is the y-axis. Okay, so you can see, right, draw graph is after you carry experiment already. So we use experiment punya variable. Okay, and last one, explain the relationship between number of gas bubble and the distance of light. This one is just like hypothesis. As the what increase, the what increase. But instead of using light intensity and rate of photosynthesis, you use this one. Okay. Is the hypothesis accepted because operation MV and RV is different than the actual? No. Yes, it's accepted because in the experiment, you just change it. But in the end, this represent this represent this. So yes, it's still accepted. Because when you do experiment, you got to change the light. What you're going to use as light? You're going to use the lamp distance as your light. Means you need something to control the light. So definitely sometimes it will be different one. But in the end, your outcome is the same. Understand or not? So yes, it's still accepted. It's still the same thing. Okay. Yeah. So graph draw yourself. We did that so many times today already. Relationship is just hypothesis. Okay. And yep, that's it lah. So all of the questions here you can see, right, is all scientific investigation punya questions. So in first term, chapter 1 punya structure is literally ask scientific investigation punya question. I have answers behind here already for all objective and structure question. Own self go and do. Okay, that's it lah for today. Goodbye. Next week we'll do continue chapter 5. Bye bye. Good night.